Continuing example 7-1, what I have is I have that interval written down, 52.337 and 55.663. So what this means is if you type all of this into your calculator, you should get something like this. And if you type all of this into your calculator, you should get something on the other side. So what the calculator does is, because the formula is programmed into your calculator, it does this faster. What I'm interested in you doing is you should be able to read this off. So this is a lower bound of the interval, this is the upper bound of the interval. So if we are interested in the mean time of the car being in the parking lot, according to this sample, how should we write this down? A researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevrolet Aveo. So according to our sample, and this is something that you can do, you can write this down, and this should be included in every single one of your homework problems. The sentence is what I'm actually grading. According to the sample, the number of days it takes an automobile dealer to sell this car, Chevrolet Aveo, should be between, and what you're doing is you're giving me these numbers with units. So if it makes sense to put a decimal, then do it. If it doesn't make sense, don't. So round correctly, and that should do the trick. It should be between 52.3 days and 55.7 days. So does it make sense to write half a day? Maybe it does, maybe it doesn't. So the rounding is not as important at this point. As long as you round correctly, it should do the trick. But what I'm interested in the most is the units. So, and the sentence making sense. So dealer to sell Chevrolet Aveo should be between 52.3 days and 55.7 days with 95% confidence. So this 95% confidence, you can stick it either at the very end or at the very beginning. According to the sample, the number of days it takes an automobile dealer to sell Chevrolet Aveo with 95% confidence, so you can stick it right in the middle, should be between. So whatever makes sense to you as far as writing the sentence. So this is what I want to concentrate, and this is what we're going to be working on in class, is getting those intervals, pushing the right buttons, and writing the sentences out. I just want to finish the next couple of examples that are in 7.1, but then you'll notice that as we move through the chapter, the problems will start to look similar. So let's move to the next example, 7-2. A large urgent care center with 4 doctors found that they can see an average of 18 patients per hour. Assume the standard deviation is 3.2. A random sample of 42 hours was selected. Find the 99% confidence interval of the mean. So what you need to do is you need to highlight things first. The fact that it's 4 doctors does not come into play. We have an average. So they gave me an X bar. They didn't say population standard deviation, but that's what they meant. I think it's a typo in the book, or we don't actually need it because it says it's a large urgent care. I think we still need it, but we're going to label it as sigma because we're in section 7-1. A random sample of 42 gave me an N and a 99% confidence. Just means that you're doing this by hand. If you're doing this by hand, you can look up the z-score that corresponds to the middle 99%. So what I'm going to do is I'm just writing down the steps on how to enter this in a calculator. You're going to push stat over to tests, over to z-interval. Once you push the z-interval, then you need to input this information as stats, as statistics. Enter sigma, x bar, n, and in this case 0.99, and confidence level, I'll just put it as C. Okay, so what I'm doing is I'm entering 3.2 right here under sigma. I am entering 18 for the x bar. I'm entering 42 for n, and it's a 99% confidence interval, so I'm entering 0.99 for my confidence. If I push calculate, what it does, it just spits it out. I have 16.728 comma 19.272. And now I'm going to ask you a question: what is the units? And the units should be, it's an average of 18 patients per hour, so we are talking about a unit that's a patient. And in this case, it really doesn't make any sense for you to give decimals in your final answer. You cannot possibly have 16.7 patients. So what you can do is you can use rounding techniques. Some books will tell you you need to round confidence, you need to round conservative, meaning to the left of the lower bound and to the right of the upper bound. Some books will tell you just round correctly to the nearest integer, and that should be fine. So that's what this book is doing. It says, well, just round correctly to the nearest integer, because giving decimals in the final answer does not make any sense. So this is what my final answer should look like. I'm going to read the original problem because this will give me the setup of my sentence. A large urgent care center, they found that they can see an average of 18 patients an hour. So with 99% confidence, we can estimate that this hospital can see on average between, and then you just round, 16.7 rounds up to 17, so an average between 17 and 19.2 rounds down to 19, so on average between 17 to 19 patients per hour. All right. My next example requires a calculator because this one is on data. So I'm going to switch over to my last portion of the 7-1, and this is called sample size. A sample size uses a formula. Let me move this over. And I'm going to switch those two. A sample size has a formula of Z alpha over 2 according to your confidence level times sigma divided by E squared. Now all of this is pretty self-explanatory except for the E. E is the error. I would like to box this formula because this one is not programmed into your calculator. This is something that you have to do on your own. So what this allows us to do is to figure out the sample size necessary in order to go through estimations. If we have information, like an example 7-4, where we're given everything that is necessary in order to find the sample size. A sociologist wishes to estimate the average number of automobiles left in a large city per day within 2 automobiles. So this 2 that is given to me, that's my estimation error. So that's my margin of error. So this is when they gave me an E. So E is equal to 2. He wishes to be 99% confident. So this will allow me 99% confidence. And from previous study, the standard deviation was found to be 4.2. So I think they do mean standard deviation of the population. I'm just moving this a little bit further down. And all they're asking us to do is how many days should he select to survey. So you can always look up the Z that corresponds to 99%. So the book is using 2.58. You can go ahead and use 2.58. Now what I'm going to do is I can multiply this by 4.2 that is given to me at a sigma, and then divide this by 2, which is given to me as an error. You need to square this. Type all of this into your calculator. So I'm doing 258 times 4.2 divided by 2, and then squaring everything. So the calculator spit out 29.35. Now except the sample size cannot possibly be a decimal. So in this case, this is the only rounding that is non-ordinary because you always round up. The always round up allows you to not forget about this third of a person who has an opinion. So what you need is you need to go up to 30 in this case. So the sample size has to be 30, and then figure out what the units are. Automobile theft is in a large city per day within 2 automobiles. So the sample size has to be 30 automobiles. it does not make sense if you put 29.35 automobiles. This leaves me with the last problem in the book, which is 7-3, that requires you to enter everything in the calculator. So I will read this problem and write a few things down and switch over to a calculator problem, calculator video. I have a data. It's in the book. It's example 7-3. The following data represents a random sample of assets of 30 credit unions in the southwestern Pennsylvania. Assume the population standard deviation is 14.405. Find the 90% confidence. So all they gave us is they gave me a sample size, they gave me a sigma, and they gave me the fact that it has to be a 90% confidence. Now in the book is the list. So what I'm going to do is I will end this video and start this on a calculator.